Okay, so in here, I'm going to try to show you how this compounding factor comes about. So our compounding factor is 1 plus the term rate, and that is raised to the exponent of n, which simply means the number of terms that we would have in total. So that could be n. All right, so let's assume that n is equal to 1. Okay, so n is equal to 1. So what would our result be? Well, since we started with $1 and we have grown an interest of I, then at the end of term 1 or at the start of term 2, we would basically have $1 plus our I. That's all that we would have. And that would be right here. So 1 plus I. That's for n is equal to 1. Now, let's take a look and see what happens if you have n is equal to 2. If n is equal to 2, so we are right here, then what we have is the following. We are starting now with 1 plus I. That's our starting point. Plus, we're supposed to be adding our interest. But what is our interest? Our interest is always the principal multiplied by our I, right? But what is our principal? Our principal, our starting point is this. So we are starting here with 1 plus I, and we're supposed to multiply that by I to obtain, okay, our new endpoint. So this looks kind of weird, but notice, if you know a little bit about factoring, I have 1 plus I in this term and in this term. So what I can do is I can factor this out. So if I factor this out, so don't forget there's a 1 in front of here. Okay, so I'm going to factor out the 1 plus I. So if I'm going to factor it out, I'm going to get 1 plus I. And then what do I have left over? Okay, I have this 1 left over plus this I left over. And notice what has happened. You have 1 plus I multiplied by 1 plus I, which is nothing else but 1 plus I to the 2. And that is at the end of term 2. So notice that your formula is starting coming into play. So what it is saying is, well, if n is equal to 1, it's 1 plus I to the power of 1, which is just 1 plus I. Now we have seen when n is equal to 2, it is simply 1 plus I to the power of 2. So you can guess, okay, what is n is equal to 3. Now let's do it anyways, okay, just as an overkill. So now what we're starting with, okay, so right here, so this is our starting point. This is 1 plus I to the power of 2. That's our starting point. That's at the end of term 2, right? That's what we had. So if we now want to see n is equal to 3, okay, so our starting point. So how much money do we have? We have 1 plus I to the power of 2 plus, just as we did in n is equal to 2, we have to add the interest. But the interest is always the amount of money that you started with multiplied by I. And again, notice that I have 1 plus I to the power of 2 here, 1 plus I to the power of 2 here. And again, I have a 1 in front. So I can do exactly the same trick and factor out, and I will get 1 plus I to the power of 2. So I'm factoring this out. And then what I have left over is I have 1 left over plus I left over. And again, if you know a little bit about exponents, so you have the same base here. So I have 2 here. This is really 1 there. So I get 1 plus I to the 3. And as you're noticing, we can continue this. And we can actually prove it by induction if necessary, but I don't think that's necessary because I hope that you can see, okay, by just playing with this, how this formula of the compounding factor comes about. So it's not from magic, it's just literally you can do it one by one and see it. So I hope that you found this useful. Not everybody will actually care, but some will do care. Okay, I definitely like to know where some stuff is coming from. All right, thank you for watching.